Hi, and welcome to this talk about hosting Theia in the cloud. My name is Simon from EclipseSource, and we will be looking at this topic today from the perspective of our open source tool, Theia Cloud, and the lessons we learned while developing Theia Cloud and with it deploying Theia to the cloud. So first of all, what is Theia Cloud? The goal of the project was to simplify the deployment of Theia applications because we just noticed that there is a huge need for such a tool out there because a lot of people overlook that step of the development phase in their projects. Some key facts I want to mention here are, first of all, it is an open source framework that covers the main requirements for cloud deployment and is especially tailored for Theia applications. And lastly, a little bit of background, technical background information. It is a lightweight abstraction on top of Kubernetes, and we will go into detail a little bit more later on what this actually means. But for those who are familiar with Kubernetes, they might ask themselves the question now of, why can't I just use Kubernetes directly to deploy my application? What do I need Theia Cloud for? And the short answer to that question would be that yes, you can do that, but I would encourage you to keep listening first. Because what are we going to talk about? So unfortunately, due to the time format of this talk, this cannot be a detailed description on Theia Cloud's architecture, but if you're interested in that, you can listen to last year's talk about this topic, which is linked here on the slides. What this talk will be highlighting is, first of all, I will provide a small introduction to Theia Cloud, just so that we are all on the same page about what we are talking about here. And then I want to show you some example features of Theia Cloud while discussing the challenges we had while developing them, and again, while deploying to the cloud. And all that so that in the end, you can decide for your own whether or not you want to use Theia Cloud or use a custom solution, basically. But before we take a look at Theia Cloud, let's take a step back. I need to describe to you how this would look if you were just using plain Kubernetes so that we can then later on compare it to Theia Cloud. And for that, I want to introduce one of the core principles of Kubernetes to you, which are these resources here. And in this case, it is a resource of a pod. And what we do with it is we apply it to a Kubernetes cluster. And Kubernetes will then go ahead and create real objects, in this case, a pod for us based on the information provided on this resource. And you can think for a pod, you can think of it as just a running Docker image, basically. And here we tell it this pod to run the Theia Cloud demo pod. And now in a perfect world, this would be all what we need to deploy Theia using Kubernetes, but that's just not the case, because in Kubernetes, you then also need to provide a service for networking, some persistent volume for storage information. You need a persistent volume claim. You need to update your pod to use all of the stuff I just mentioned. And let's say, for example, you now want to add authentication to your tool. You will need a deployment for Keycloak, which instead also needs a service and needs also a persistent volume claim. And I did not explain all of these concepts now in detail because they will become obsolete in a second. But what you might now already see is that a very simple deployment using just authentication and attaching a workspace to your pod already takes quite a lot of Kubernetes knowledge to get it up and running, because you need to deal with all of those kinds of resources. And this is now also the entry point where Theia Cloud comes into the picture, because I said before that it is a lightweight abstraction on top of Kubernetes. So it does not try to replace Kubernetes, it just adds an additional layer on top of it and uses some of Kubernetes concepts to ease that deployment for you, and so that you don't need to deal with all of this. And therefore, we want to look at those concepts. And the first one is our so-called custom resource definitions. Those are basically blueprints for custom resources. And custom resources, as opposed to resources we just looked at, are just custom types of resources that we can apply to the cluster. And the benefit now is that in Theia Cloud, we don't need to deal with like 7 of those or like even more, but we just need 3 of them. So we first of all need an app definition, which is just the description of the application that you want to run. We need a workspace, which is the storage you want to use. And lastly, we have the session. The session one, I will show you the definition for it, because it's also the description of a session inside of Theia Cloud. So here we define a session to needs to consist of a name. It needs to provide a workspace that we want to run, and we need to tell it what app definition we want to run and which user is using that session. And now we can go ahead and create actually a custom resource based on this definition. So this will then conform to the definition that we just looked at, but then provide the information. So you can think of it as something similar to the pod on the earlier slide. And for a session, this might look something like this. So we have a session X with the workspace Y running the MyTheia app, and I'm the one who's using the session. And now, since those are custom types, we now somehow need to tell Kubernetes what to do with them, because Kubernetes does not know about what should happen when such a type is applied or such a resource is applied. And this is where the operator comes into place, and its goal is basically to react on those Kubernetes custom resources and then create the Kubernetes objects based on the content. Now, this already hides quite a lot of complexity because you only need to deal with 3 of the types and not all of the types I've shown you before. But we can even take it one step further, and we provide a REST service that creates those 3 custom resource types for you. So you, in the end, only need to talk with the REST service and not deal with any resources at all. Now, what is important to note here is that in the background, the same resources will still be applied. However, this is done automatically by Theia Cloud, and you just need to interact with fewer resources or with the REST service like described. Now let's take a look at how these 3 custom resource types that we just talked about play together to, in the end, provide you with your pod or with your session that you can access. And during the initialization of a cluster, we will launch an operator that is just running. And we will also, or an admin will create now an app definition and provide the cluster with information on, for example, what image we want to run. So in this case, the Theia Cloud demo image. And then the cluster is ready. And once a user creates now another resource, so in this case, a workspace custom resource, now note here, it does not matter whether or not it is applied via the service or directly as a resource, the result will be the same. In this case, I request a new workspace Y with, let's say, 2 gigabytes of storage, and the operator will react on it and give me the Kubernetes object, so the persistent volume. But it will also align with the values I provided down here, so it will give me a persistent volume using 2 gigabytes. And now, where the magic happens, I can now also create a session custom resource that I give the name session X. And now I actually link the 2 custom resources that were created beforehand. So I link the workspace Y and the MyTheia app, and I say I'm the user who's running it. And the operator will again react on this and will provide me with the pod running the session X using the MyTheia app, and will connect the persistent volume because we also connected it down here. And now note, this is only a simplification on this side of the operator. So there are many more types that are being, or resources that are being created, or objects that are being created. So for example, services and so on. But the side down here stays the same. So you really get a big abstraction layer where you only need to deal with these 3 resource types. So now that all sounds great, and maybe your question from the beginning might have now shifted to something like, maybe I should just build my own abstraction on top of Kubernetes, because that sounds really cool and it seems to be very helpful. And this is the point of the presentation where I would like to go over some of the hidden challenges we had while developing Theia Cloud. Why do I say hidden challenges? Because you might all know this imagery of an iceberg, where on top of the water you have the core functionalities, which we would estimate in Theia Cloud were only about 20% of the development efforts that we have spent. And you actually have the hidden challenges, which are like around 80% to our estimate, which consists of peripheral functionalities, so everything that are not core functionalities and is not there to support the basic use case of hosting the application to the cloud. And some areas of where these functionalities come from, or these requirements, you could also say, are first of all security. Then you have hardening, you have monitoring, you have upgrades and updates to the deployment as well as your application. And lastly, building and testing the whole deployment. And what I want to do now is go over these 5 areas, look at some of the requirements, and maybe show you some of the things that you might miss in the beginning, that are hidden in the beginning, and also give you some of the features that we developed in Theia Cloud, so you don't have to deal with all of those hidden challenges. Starting with security, the requirement here is relatively obvious. We want to make the deployment secure. But what is maybe a little bit less obvious, but still quite obvious, is that there are a lot of cloud-specific threats now since we are deploying to the cloud. And I cannot name here everything because, again, for me, also some parts might be hidden. But you can now imagine that this tree continues with a lot of threats and so on, and it will just keep growing the longer you dig into the topic. One of those issues might be, for example, that you will need to deal with access management because now your application is out there in the wild and everybody could access it, but you might only want people that are paying for it to access it. And lastly, you also, for example, need to deal with harmful user inputs or just overall harmful user behavior because they are not running on their machines, but they are running on your cluster and your resources, therefore. And for hardening, the requirement is that you want to make the deployment resilient against unexpected scenarios, for example. And one of those that we noticed very early on is that you will have to deal with crashes of your components. So, for example, your operator might crash for various reasons, and that's just not good because then the availability of your program goes down. One thing to mitigate this might be to handle having incorrect resources on the cluster so that the operator knows, okay, if the image, for example, in an app definition is missing, I cannot handle this. But there's even a better way that you might find out only after a certain amount of time that you spend on it. And that is that you can actually avoid those resources in the first place being applied to the cluster at all. So you don't need to deal with them because they are never allowed to access or to go onto the cluster. And this I can actually show you because in Theia Cloud, we are using custom resource validation. So let's switch over to the demo. Here, basically, I have a console that is connected to a cluster. And here I prepared a session custom resource that I now want to apply to the cluster. So I provided an app definition and a name for it. And if I now apply it via the CLI, we can see that it gives me the feedback that this is invalid because the user is missing. And now if you think back when I told you what a session in the context of Theia Cloud it is an app definition running for a specific user, so it makes sense that you need to have a user field there. And if we now apply the fixed resource again, we can see that it was now actually being created. Beforehand, it was blocked. And if we now take a look at all the sessions that are on the cluster at the moment, we can see that the one that we have just created is indeed on the cluster now. And now, just to quickly recap, this of course already takes away a lot of reasons for why your operator, for example, might crash. Then let's continue with monitoring. Again, relatively obvious, you want to monitor your deployment, but there are certain aspects of it that you might need to find out about. So first of all, you want to monitor for the usage of the resources inside the sessions, because if a user uses a lot of resources, it will cost you money, which is not good. On the other hand, if a user is not using your sessions at all, you might also want to shut them down. So you want some sort of activity monitoring to make sure that the resources you are spending or you are paying money for are actually being used. And maybe to go into another direction, after something went wrong, you might also want to be able to debug the deployment. And since you set the deployment up without any Kubernetes knowledge, you might also want to be able to debug it without any Kubernetes knowledge. And that's why we write the status of a specific resource directly to the resource, so you don't need to traverse any Kubernetes logs. And I can also show you that. So we now applied this this session in the earlier step. And if I now take a look at it on the cluster, we will see that it was being created, and here are the fields that I specified, but there is actually this additional status field, and it tells me that there was an error on the operator because the app definition was not found. So we tried to reference the wrong Theia Cloud demo, which is already quite the hint, but if we take a look at what app definitions we actually have available, we can see that we only have the Theia Cloud app definition available. So if we now fix this, and then remove the old errored resource and then apply the fixed one again, which should again work because we didn't break it or didn't change something severe here. And then take a look at it. We can now see that the operator status was now set to handled because everything went well, and we were able to properly handle the session and bring up a pod for it. Then for upgrades and updates, you want to be able to update your deployment. One of the things you might investigate there is that you want to update without downtime. You then also need to ensure that there is compatibility between all of your components, which is not that easy than you might expect in the beginning. And lastly, for example, to get an update without downtime, you need to be able to properly update the custom resource definitions if something in the base framework basically changes. And this took some time to investigate this and make sure to get this right so that it in the end really runs without downtime. And then lastly, build and test. So you want to test updates to your application in the cloud because you will deploy it to the cloud, so it makes sense to test there. And therefore, you need to, first of all, be able to support multiple versions. Otherwise, you would need to set up a new cluster for each test version, which is a lot of effort. Once you've done that, you also need to be able to communicate the desired version that you want to run through the cluster, because if there are multiple versions, which one should Kubernetes give you in the end? And then lastly, you need to think of ways to make the new version available to reviewers, for example. And for that, I can show you another quick demo of our PR preview feature. And for that, let's take a look here at GitHub, where I created a pull request with just one simple change, and that is that I changed the name of the application that is hosted inside of this repository to TheiaCon talk. And as soon as I opened the pull request, a comment appeared where it tells me, okay, you can now take a look at the newly built image here. And this brings me to a page where I can request a new session for this version of the application. And if I do that, and while this loads, I can show you what actually happened in the background. So somewhere we have this Kubernetes cluster running with Theia Cloud installed, and then the pull request is being created, and the pull request will then build and upload the Docker image of the application to a Docker registry. And we can then create a new app definition on the cluster with some identifier linking it to the pull request that uses this pushed Docker image. And then all we need to do is we need to comment the URL, just like we saw on the pull request, that points me to a page where I can request a session using that app definition, which you also saw in the parameter here that we want something for the app definition 80. And now in the meantime, this has loaded. And if I now go to the About section where you can see the title of the application, you can see that it was changed to TheiaCon talk. Now, why this is a very easy to demo example, of course, you can change whatever you want inside your Docker image. It does not have to be only the name. So what are the benefits of all of this? So first of all, by using Theia Cloud, you will gain a lot of efficiency because you need to deal with less complexity since it hides a lot of aspects of Kubernetes or simplifies them. The resources that you are dealing with are tailored to hosting Theia applications. And overall, you will just get a reduced time to get started because you don't need to deal with all of the stuff that I just mentioned. And maybe only advanced topics need to be investigated. Second of all, you still have great flexibility because there are customizations to this abstraction layer possible. So for example, you can just use a custom operator service or landing page or whatever. And you can also integrate this into your existing platform by just using the REST service. So you don't even need to switch your platform, for example, if you don't want to do that. Then we have resource optimization. So this is, of course, a hard topic to quantify, but what we can promise basically is that learnings from other consumers of Theia Cloud will grow together into a huge set of best practices inside of Theia Cloud. So for example, we were already able to gain experiences with multiple cluster providers like AWS or the Google Kubernetes engine, or advanced features like auto-scaling. Then you also get the built-in integrations for common services and tools that I've just presented, like, for example, the monitoring right on the custom resources without having to traverse the Kubernetes logs, or the PR preview feature you just saw. And lastly, sustainability. So what an open source project basically does is it builds some sort of consistency for the terminology. So we now all know what a session is and what a workspace is. So those terms are differentiated. And also you get a lot of best practices and just one source of best practices on how to do the deployment, basically. This also comes with a growing community and ecosystem, which then instead also means that you will get continued development and maintenance for some of the features we just talked about, because other people may have investigated into it and then contributed it back to Theia Cloud. So if we sparked your interest or you have any questions, you can visit our website, check out our hosted demo tools online by clicking on these links here on the slides, or just write us an email, which is linked here, or you can ask them now. And as I can see, there is already one question. Can I use Theia Cloud with my custom container orchestration platform? I would need to know what exactly the specifics of the custom container orchestration platform are, so what the custom part basically is, but in theory, I don't see any issue working that, because Theia Cloud basically only defines like these custom resource definitions and provides like interfaces between components on how they can communicate with each other. And like I said, using all of the by providing custom components, you can just tailor it to your needs. And depending on how custom your solution is, the more complex those changes might be, but they might also be very simple. Then there's a second question. Are there any plans to implement more widgets like the 3 editor for Theia? For instance, something like the Nebula Grid for SWT. Unfortunately, I'm not quite sure how this is connected to this presentation, and I'm no SWT expert, so I cannot answer this question. And another question is, how expensive is hosting cloud IDEs? Again, it's really hard to put out some real numbers there, and it widely depends on what your needs are. Depending on how many users you want to be able to use your platform at the same time, for example, is a huge factor. So it might be relatively cheap to just have like the demo applications that we have here linked, if they are restricted for 10 users at a time for a specific application. So then it is, of course, much less expensive than wanting to have thousands of people at the same time over different continents, for example, using your tool. So, but this is also one of the biggest advantages of Kubernetes, is that the scalability is just given, and you can just scale as your business or your application grows, basically. I hope this answers the question. So as I see there are no more questions, I would like to thank you for your attention and have a nice rest of your time at TheiaCon. Thank you.